Today, the Big Bang Theory makes tons of predictions that are provably in conflict with at least a dozen different data sets. And when this happens, and when this has happened repeatedly since the 1970s, instead of saying the Big Bang Theory is wrong, which is the scientific conclusion, that it's not valid, that the universe isn't expanding, they do the Ptolemaic trick. They say, well, we're going to alter the theory, always making it more complicated, and fit the data we already have, and produce new predictions, which are always going to be wrong. And I have seen people, on the videos say, this is good science. This is the way science goes. We as scientists are excited when we're proven wrong. And no, that's not science. That's the Ptolemaic method. So can I point out some examples of this? Because I really
Please,
think,
yes.
yeah. So as I say, there are a dozen, more than we really have time for. But let me just pick sort of my favorite. And they're my favorite because they've been strengthened. Contradiction with observations has been strengthened in the past couple of years. So let's look at some basic predictions that the Big Bang makes. The Big Bang says that the universe went through a hot, dense period. Hot, dense matter has to produce fusion reactions. That's the only place fusion reactions really exist in large numbers. You have to have the heat, you have to have the density, the temperature and the density.
Except for lattice confined fusion, but that's maybe an edge
All
case
right,
we'll
well,
deal with some other time.
I said in large amounts. You can't have fusion in large amounts without having temperature and density. As a result of this, the Big Bang produces a specified amount of helium-4, the second largest amount of matter in the universe is helium-4, normal helium, and lithium. And the isotope of hydrogen, deuterium. So these are firm predictions. And as the theory became more elaborate, became related to the variations in the cosmic microwave background, these predictions became more and more exact. And they're completely wrong. So helium is predicted to be approximately 24%. I mean, they have several more decimal places. And we see in more and more observations of helium, both in stars and in interstellar medium, as you get older and older stars, and we can see that they're older because they have less heavier elements in them, which everybody agrees are produced by supernova, the amount of helium gets less and less. So we see a slope downward to at least 11%. And 11% is many, many standard deviations less than their predictions of 24.7%. So that's a complete contradiction that there's no way around. It's a very firm prediction. Lithium. So lithium and, okay, the other side of this, it's a firm prediction of the non-expanding model, which uses, existing physics demonstrated in the laboratory that says this helium must have been produced in the early history of every galaxy by stars like our sun, producing helium by thermonuclear fusion in stars. And it would show that the older the star, the less the helium. And it's quantitatively verified by observations. So that's example number one. Lithium, the same thing. Lithium is supposed to be produced at the level of approximately 4 to 6 times 10 to the 10th. So that's 0.6 to 0.4 parts per billion compared with hydrogen. No, that's not the observations. Observations is that as you again move to older and older stars with less and less of the heavy elements, there's a plateau that's a quarter the level of the predicted plateau. And then you get to the purest, the oldest stars, there's a slope straight down to zero. So to unobservable levels of lithium. Again, without an expanding universe, you can predict on the basis of plasma theory, known cosmic ray cross sections, that the lithium can be produced entirely by cosmic rays produced by stars in galaxies like our own. So that's number two.
Tired of inflation, wars, and inequality caused by the energy crisis? LPPFusion is developing a solution that could allow everyone to have cheap, clean, off-grid, and sustainable fusion energy. Invest now as we seek to bring this potentially life-changing technology to market. For more information, visit wefunder.com/LPPFusion.